Hi, I want to introduce myself. I am Ken Langdon. I'm a solutions architect for Chef Software. I've met some of you and know some of you, and thank you so much for being here. We all know that Chef has this desire to make IT better, and thus businesses move faster and add business value, right? So everybody knows that. Well, our speaker today has a desire that sets him apart and is why I admire him immensely. So we were at the bar a couple nights ago, and my plus one was there, and we were sharing some stories about our IT careers. Hey, where did we come from? How did we end up where we were at? He shared this story. He's like, well, this last gig, I had a choice. I could have gone to work with some friends at a company. It's like, it wouldn't have been the best job in the world, but, I'd been with friends. It was cool. And he said, but you know what? I have this desire to solve problems. And I was like, oh, yeah, me too. That's why I code, man. Solving problems with software is so cool. And he said, no. I want to seek these problems that a fraction of the population can solve. And I was like, whoa, okay, I don't know if I can compete with that. And so to that end, he's the DevOps leader at the Intelligent Retail Lab, which is a very large retailer, as we all know. And so please help me and join me in welcoming Jeff Moody.
Thank you, Ken. There we go, clicker works. So yes, as Ken said, I run the DevOps organization for the Intelligent Retail Lab Restart. I run the DevOps organization for the Intelligent Retail Lab by Walmart. So the Intelligent Retail Lab is a part of the Store Number 8 family of companies. Store Number 8 is a technology incubator that Walmart started a couple years ago. And Store Number 8 really focuses on exploring emergent technologies and seeing what weird things we can do and how we can solve hard problems for the consumer. The Store Number 8 brand comes from Sam Walton. Back in the day, had a store near his house that was the 8th Walmart store, which is where we get our name from. So the Intelligent Retail Lab, we are seeking to take and apply artificial intelligence in a retail environment. So we have a neighborhood market store in Long Island, New York, that for a year and a half, we've been equipping with a lot of sensors, we've been equipping with a lot of equipment to be able to try and see what artificial intelligence can do for grocery and for the customer. But really, we put a supercomputer in a grocery store. We have a 100-node GPU GPU-powered AI cluster that we put in a grocery store. That's actually a picture of it that you can see right there. We were initially exploring trying to put all of this equipment behind closed doors and kind of hidden away, and then realized that was going to be really difficult. So to use the words of one of our directors, we decided to Krispy Kreme it. And so we decided, instead of trying to make this an ivory tower that's just magic, we wanted to pull back the covers, show people what's going on, show people how we're doing it. So why are we doing this? Well, we're a laboratory, and so we're going to be running a number of experiments. We've found, working with the larger Walmart stores organization, over 200 different use cases where Walmart and us think that artificial intelligence can solve a problem for real people today. Our first major experiment is on-shelf product availability, or as we call it, OSCA, or on-shelf customer availability. Basically trying to make sure that what you want is in the store when you want it. You might think this is a relatively simple or solved problem, but turns out it's actually way more complicated than you might realize. And today, Walmart stores have associates walk around the store looking for product outs, sending alerts that, hey, a product is out, and then someone else will go stock it. So we have a lot of sensors to be able to look at the shelves and figure out when this stuff happens closer to real time, and being able to then let the associates spend more time helping customers as opposed to looking to see what's out of stock. Additionally, we're looking for spills and hazards. We discovered that because of the angle of the cameras looking at the shelves, we can see the floor. And right now, when there's a spill in an aisle, it takes someone noticing it, calling it out, for then someone to go and resolve it. So if we can look at the floor, because we're already looking at the shelves, then we should be able to determine, hey, something's on the floor that shouldn't be, or the floor is shinier than it should be, and then be able to send someone to go clean it up. And we're working with a couple of different autonomous robot vendors to be able to get APIs, so that way we can then tell it, hey, at these coordinates, there's a spill, go clean it up. Additionally, something else that no one's ever experienced at a grocery store is you get to the front of the store and there's no shopping carts. So we're still exploring the different types of sensors we're going to look at putting and where we're going to put them for the shopping carts, but we are going to try and make it so that you'll always have a shopping cart available. So where does Chef fit in? We have 100 servers in a grocery store. We manage those servers with Chef Infra. We're experimenting with and moving to the effortless config model, but transformation takes time. We also have development environments in New Jersey and Dublin that all are managed under Chef. We're also building a lot of software in Habitat. So one of the big things that we started habitatizing is OpenCV. We don't actually use a lot of OpenCV in the store, but it's amazing for prototyping. It's the 800-pound gorilla of computer vision. So if we need to run an early stage experiment to see, is this going to be possible, our initial prototypes are almost always using OpenCV. OpenCV has about 1 million switches that can be turned on and off. And our developers were having a really, really hard time. We burned, what was it, a month and a half of literally just everyone in the organization rebuilding OpenCV every day. Because, oh, we need this flag turned on. Oh, turning that flag on breaks this. And so being able to have a core plan for us that we can toggle these switches easily and get reproducible, immutable, reproducible artifacts to be able to do this faster and easier, and then farm out the building to a bigger server in Azure or in one of our development environments, as opposed to people building it on their laptop, really, really accelerated our ability to run a lot of these early stage experiments. We also use Kafka a lot. We've found that Kafka can be a big headache to run out of band. Putting it in Habitat took, God, what is it, a 50-line Chef recipe to be able to set up Kafka, and moved it to Hab service run Kafka. We're also experimenting with Consul because we're finding service discovery between Habitat and Kubernetes to be a little bit challenging. And we also have a number of systems that just aren't fitting well in containers, which is GStreamer. So with a lot of sensors, we were finding it really, really challenging to be able to ingest all of this data, process all of this data, and do the work we need to do as close to real time as we want it without building something giant or complex. GStreamer, something that you may already be familiar with, as the audio video solution for Linux desktops, really already had all that, all those components baked in. So being able to take GStreamer and point it at all of our sensors and have this amazing data pipeline has really sped up our ability to handle all of the sensor data. So we take this data in, we transform it, we attach metadata, we can transform it, we can create visualizations. One of the things we're doing now is using GStreamer to build a very large grid of all these sensors running in real time as one giant image, which then we can pass multiple sensors at once into the AI model, which allows us to better parallelize our work, as opposed to, okay, you're looking at this sensor, now you're looking at this sensor, now you're looking at this sensor. If we can take and pack 20 camera streams into one image in real time, then we get a lot more bang for our buck from our GPUs. So when we started building GStreamer, there are so many rabbit holes to go down. There's been a lot of very good work that people in the community have done and people at Chef have done around starting a lot of kind of the X Windows and Linux desktop experience in Habitat. It's not all there, so we spent many, many months getting all of these things built so that now we are able to build GStreamer with all of the plugins. A lot of thanks to the Arch Linux community and their amazing package builds that gave me a lot of the spaghetti and holes to go down, so that way I didn't have to figure all this out the hard way with everything breaking. But we have good, bad, and ugly plugins all building, and while we aren't going to need all of these, we're in the process of getting all of these plans open source, so that way if you want to use them, all this work has been done for you. So yeah, with these sensors, we've got various protocols, various ways of getting this data across, and having to have all of our services talk all these different ways really has made life super challenging. And so being able to normalize all of the data through the GStreamer pipeline has made everything just so much easier and so much better. So we already have over 1,800 sensors in the store. We don't know what else we're going to add. And being able to normalize all of this data is really helping accelerate our speed of development. So why did we choose Habitat? Well, we initially started building all of this in Docker and trying to fit it into Kubernetes. We love Kubernetes. Kubernetes is a great system. However, the Kubernetes bare metal story still isn't a great story today. There's a lot of things that are harder to do in Kubernetes than it should be, because Kubernetes was built cloud native, and so trying to take a cloud native technology and ship it backwards introduces a lot of unique challenges. So once we spent several months wrestling with trying to get everything running under Docker and running on Kubernetes, and discovered that trying to do it in Kubernetes was just more headache than it was worth, but we could do it in Habitat. We get most all of the same benefits of Kubernetes. We actually have faster and easier deployments. We have faster immutable builds to be able to take this very large system and stop trying to put the square peg into the round hole. So, what didn't work well? If you are an open source developer, please, 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 please stop building a new build system. Like, they already exist. Many of them work. Most of them work well. Please stop reinventing the wheel. When I'm off microphone, you can ask me, and I will tell you some wonderful horror stories about trying to learn 8 different build systems in a month, because every single package wants to build its own unique way. So the next thing that we're having a bunch of opportunities to explore is getting Habitat and Kubernetes to mesh better together. We'd love to not need console, because that's another thing to keep up, something else to break, something else to monitor, maintain, manage, patch, et cetera. So to be able to get the Habitat supervisor and Kubernetes APIs to talk to each other would make life a whole lot easier. I know Kubernetes operator is a thing. Its viability is kind of in the air right now, but I know there are lots of people asking this same question and working on this problem. We also would love to move everything to Habitat, but the current containerization story in Habitat isn't the best story out there. I'm sure if you've already built software in Habitat and tried exporting it to Docker, having one giant layer that you keep sending over the wire again and again isn't the best use of resources. So I I know there are people that are working to try and build a better Docker export experience, but it's not here today. So what's next for us? We're looking at edge computing. So part of the goal of the Intelligent Retail Lab and building applied AI is being able to take that AI and scale it out to Walmart. And so while we have our one lab in Long Island, and we can do a lot of things there, it only really gets business value when it's in your neighborhood Walmart. And so being able to take and put AI models on the edge will make this more viable, because fascinatingly enough, we really don't want to put a data center and a supercomputer in every single Walmart store. That just really doesn't scale. And when you're dealing with all the fire hose of data, I think we're pushing 30, 40 gigabits per second worth of all this sensor data. There just aren't internet pipes fast enough for us to try and offload this into the cloud reasonably. And so being able to get these things on the edge is going to be very, very important to us. And I'm already working with, and Chef is working on trying to get Habitat on ARM. That's going to be very important for us. And when you get Intelligent Retail Lab sensors in your local neighborhood market, you can feel confident that it will probably be running under Habitat. Because trying to do single node Kubernetes on a Raspberry Pi is just a headache that we don't want to deal with. But having a supervisor and running services that way, checking in to automate, will make it so that once we have 300,000 sensors spread out all over the globe, we can look into those and make sure everything's working. So that's going to be super important to us. And I went through that so much faster than any other time I've ever done it. So I guess I have time for questions. If y'all have questions. Let Ken bring you the mic.
So you mentioned all the cameras in the store that we all know about.
Yep.
Has loss prevention come to talk to you?
We're really only looking at the shelves at this point in time. I'm just going to leave it there. Come on, folks, you got to have more questions than that.
I got you.
All right.
We can start. So it sounds like you're currently streaming all the data through the platform and you want to move to ARM. Are you looking at actually building custom compute on camera and streaming JSON payloads towards servers, or what does that look like?
So we honestly don't know yet. Yes, that would kind of be the ideal, is to do all of the AI processing, or as much as we can, on device, and then be able to push that up into Azure for data consolidation and data processing. But we're still really early in that stage of experimentation, so we're not sure what ultimately that will look like. I may have a talk here next year or the year after where we've figured out some of these problems. So, good question, though.
Hey there, my name's David. I work at Chef.
Hi, David.
So you mentioned a couple of edge computing kind of things, and
Yep.
I was curious if you would want Habitat to run in places that it currently doesn't run, and what those places might be.
So the main place we're really looking at right now is Raspberry Pis. We've been experimenting with a couple other types of edge compute devices. They're still ultimately ARM-based, but really it's ARM that we're focusing on, and then being able to add potentially TPUs or some sort of AI processing engine on top of a small ARM device to be able to be powered with low voltage beams or low voltage power runs. We need, if we're going to build and buy thousands and thousands of these, we need them to be inexpensive, and that really today that's ARM.
Quick question. So I realize this is ChefConf, so I shouldn't be asking, but so I noticed that console was in there.
Mm-hmm.
I was sort of curious. again, sort of what role that was trying to accomplish?
So we have GStreamer handling all of the data, and then inside of Kubernetes is where we run our AI models. And being able to have the services discover each other, right now we need to have a service discovery layer, and so that's console.
And a quick follow-up, since you've got thousands and thousands of nodes effectively, do you find it really chatty?
So we actually have very, very few systems that are talking to console. We only have 25 GStreamer appliances and 100 GPU nodes, so it's not thousands and thousands of machines talking into console. The GStreamer application needs to know what all sensors it needs to process for, but really that's kind of a static configuration map. Once we have the IP addresses for those devices, then we point GStreamer at them, and then it then needs to know, okay, who needs to listen to my data and how. And so that service discovery layer is actually not that chatty and hasn't been super hard.
Are you using this mainly as inventory control, or do you have plans to expand it to like those people that are up the street from us that start with an A, but we don't talk about them?
We've found, again, 200 plus use cases for applied AI. Early days, we were looking at doing bigger, broader scope work, but we really are finding that a lot of these are not solved problems. And so being able to try and solve one problem at a time and provide a lot more value to the business really has been kind of our mission for the last year. And so we're really just kind of looking at the shelves and looking to see what is and isn't in stock. Because when we can make sure a product is in stock and in the store, people can buy it. And if people can buy it, then they're happier because they have what they want.
You mentioned that you replaced Kubernetes with Habitat, and this is, right?
So we didn't replace Kubernetes with Habitat. We still run Kubernetes. We still very much love Kubernetes. There's just in IT, we have a bad habit of, here's the shiny new tool, let's fit everything into the shiny new tool. And so we really were trying to force something into Kubernetes that didn't work well in Kubernetes. And so that's a lot of our takeaway, and has been, rather than trying to force the solution into a tool, we should probably spend more time making sure we have the right tool for the job. And with the right tool for the job, then the process just gets so much easier. The Habitat Supervisor gives us a lot of the benefits of Kubernetes without the constraints of Kubernetes. And a lot of times those constraints are valuable, but other times those constraints made life way harder than it needed to be.
Could you go into that a little bit? Because I haven't really thought of those two technologies as being able to replace each other. So what are the things that you were able to do better with Kubernetes and better with Habitat?
So a lot of the networking components of Kubernetes is just, it makes life easier as you swap and replace things. Having the container networking overlay to be able to get our microservices to talk to each other is just easier. Scheduling one-off jobs and periodic tasks in Kubernetes is way easier than in the supervisor. I know there are ways to, but then you're building your own job queuing system or you're building your own scheduling system. But being able to run a cron job in Kubernetes is as easy as writing a YAML and applying that YAML. But Docker being Docker, there's a number of constraints around how you attach to storage, how you can access devices on the host. And so in a lot of those places, we found Kubernetes was actually causing us a lot more pain and needing a lot more engineering time to try and solve. And so removing those constraints, because the Habitat Supervisor is just a Linux process. You're just running a process, not even in a container or a chroot or any sort of jail on the box. You're just running a Linux process. So then we have access to all the resources that the machine has. Did that answer your question? Welcome.
You talked about building like custom packages in Habitat with OpenCV and I think GStreamer.
Yep.
Did you spend a lot of time before that trying to Dockerize that? Like I years ago I struggled with OpenCV compilation, and I understand how tricky that can be. I'm just wondering, it's not like you're taking advantage of the Habitat channels deployment supervisor stuff as much. It sounds like you're just using it mostly for packaging, and I'm just curious how much time you spend on each side.
Well,
of things.
we're there to rewind to my cute bunny slide. There were so many rabbit holes for us to go down and so many fundamental libraries that still didn't exist in the core plans. So we've spent a lot more time building those libraries. We actually just have the first GStreamer services running within the last month. And so now that we finally have services running, we're going to take more advantage of all the other things that Habitat provides. But we did have to do a lot of groundwork to be able to get it so that the software could be built and could run. We did try Dockerizing a lot of this, but again, having to deal with, okay, now we've got 30 different container images, and those are out of date, and having to rebuild it all the time was a bigger headache than being able to push it into the builder that can handle a lot of those automatic rebuilds, for us to say, hey, you updated, Jasper, and so now everything that depends on Jasper can be queued up for rebuild. Took all of that work where we would have to queue up builds for Docker containers and just takes all of that pain away from us. Say what? Yes.
Hi, David again. So I like a good build challenge, and I would love to get a list of things that aren't in core plans that you would like to be in core plans.
Well, we've got everything already built, so there's going to be a lot of pull requests coming into core in the not too distant future.
Oh, that's awesome. I'm excited.
Yeah, we've already got them built. It's just a matter of, being part of Fortune 1, there's obviously some review processes that we're going through. But given that it's just building and packaging other open source solutions, there hasn't really been any hurdles there. So I don't have any timelines as to when those pull requests will be coming, but it will be happening in the future.
I'll grab your contact info, and that way we can work with the other core maintainers to help shepherd those in.
Excellent.
Oh, never mind.
Okay.
No, my name's Chris, and I'm actually just going back to school and working on my bachelor's in computer science. And so I've always been asking people what languages or where, because our school was mainly Microsoft, and we worked a lot with C#, and now and SQL, and now I've been kind of moving over to .core, which I really enjoy. Where would you, as a basic, from
I'm a polyglot. I know enough of a lot of languages to be dangerous and a bad developer in all of them. Like a lot of, well, it really kind of depends on what you're looking to do. We're predominantly a TypeScript shop. We've found that to be a really pleasant experience for our microservices. But when it comes to building artificial intelligence models, basically there's only one choice, and that's Python. We've been building a handful of applications in Rust. We use a little bit of Go. Really, it's kind of the best tool for the job. Again, going to my next to last slide of finding what the best tool for the job is, so that way you're not trying to fit square pegs into round holes.
Yeah.
That being said, one of Walmart's child companies, Jet, is a big F# shop, and they love it. We have a handful of engineers that came to us in the Intelligent Retail Lab from Jet, and I think at least once a month I hear, oh man, if we could only build this in F#. So, everyone's going to have their own opinions. My personal opinion is find what works well for you and run with that.
Yeah, because I was looking at getting into predictive data, but have all this data and start using it, like traffic, So you have all this traffic data historical, and all you have weather traffic. So on Thursdays, if the weather's this, so.
Yeah, a lot of those big data and data science problems tend to be better in Python, just the community's there. But yeah, we are actually moving to running some of our AI in TypeScript. It's a bigger lift and is taking more brain power to do it, but we're solving problems in the languages that we're finding benefits from. You're very welcome.
Have you thought about other places this technology you're developing would be useful, other industries, other than just looking at shelves?
So one of the other places that we're, today we're looking at the shelves out on the sales floor. One of our next logical steps is going to then be looking at the shelves in the back room to make sure, okay, it's not on the shelf, it's not in top stock, so let's see if it's in the back. And once we have a system for looking in the back room, then I can't say for sure we'll apply that to warehousing and logistics, but it seems like a logical next step. There are probably other avenues or ways of taking our learnings and applying them in different industries, but right now we're really kind of focused on our on-shelf product availability.
Are you looking at any rogue carts in the parking lots?
Not today, but we are looking for that in the future because, no one likes to have the shopping cart hit their car.
I agree.
So, if we can see it's running away, then we can send someone to get it, whereas right now, trying to have an associate sit out there full time and just look at shopping carts, no one wants that job.
I want to see the robot that chases down the carts.
Yeah, I think we're a long time before that's going to happen. Nothing else? Well, thank you all very much.
Jeff, thank you so much, Jeff.